Okay, so let's get back to where we left off yesterday. Okay, if a plane burns 34 liters of fuel per second. Now again, the per comes up. Per means a fraction. That means it's a conversion factor. Okay, so we've got, now I'm going to show you a way that a lot of students like. What they do is they put the conversion factors available to them on the right. So this is the first one we're going to come to. Okay, remember all conversion factors have an inverse. Okay. All right. And they want you to calculate gallons per hour. So what's given?
$34
Per second. So what's given is a fraction. Now remember, fractions are two problems. You're going to solve for the numerator and solve for the denominator. Okay, and what are we trying to calculate? We want to calculate gallons per hour. So this is the two problems: liters to gallons and seconds to hours. Doesn't matter which one you do first. So let's do seconds to hours. Are there any questions about these fraction problems? A lot of people have problems with them. They're not any harder than the other. They're just harder to recognize that it's a fraction given. So fraction given, fraction calculated. Okay, so let's do the time part first. We need to get seconds to hours. Okay, now we're in hours. Okay, now we need to figure out going from liters to gallons. Okay, so let's look at our conversions over here. Okay, we've got a liter to gallon conversion. It's boldface, meaning it's by definition infinite significant figures. Okay, 3785. We're going to remember that. Okay, so what goes on the bottom? What goes on the top? I'm going to use this conversion factor, 3785. Remember, given always has to cancel. Our given is liters. So to cancel liters, where does liter need to go in the conversion factor? The bottom, right? So that means it's going to be that way the liters cancel. What are we left with now? Gallons per hour. Okay, does this make sense? Every problem we're doing, we do given to calculate. Yeah. Correct. So you go 34 times 60 times 60 divided by 3785, just like you said, exactly. Okay, so we've got two sig figs, infinite, infinite, and this was boldface, so it's infinite as well. So our answer is going to be two sig figs, which is okay, so that's 3.2 10 to the fourth gallons per hour. And again, I remind you, 90%, 10%. Okay, is everyone okay with that? Okay. Now this is tricky because most students have never done this before. How many square inches are in 49 square meters? Now, if you look at our conversion, it's only length. It's not square or cubic anything. So we have to convert the lengths to square. Okay. So we're working with inches and meters. Okay, so we've got we can get inches to centimeters, and we can go from centimeters to meters. A two-step problem. However, we have to convert it though to the square versions of these. Okay, so we're starting with 49.3 square meters. And we want to go to square inches. Okay. So we have 254 centimeters per meter. And then we've got okay, now we're going to convert these to square inches and square meters. To do that, we're going to square it. Now, if you square everything, if you square parentheses, you also square at the same time everything inside the parentheses. So that means we're squaring this, this, and that. Okay? So we're generating our own conversion factors here. Okay, so 2.54. There's two ways to do this. You can do the math on the conversion factor first, then plug it in, or you can just put it into the run here and do it as you are doing it. Okay, so let's do it. Let's square it first. So 2.54 squared is okay. Does everyone see where the 645 came from? And we squared the 254. Okay, same here. 100 squared we go 100 times 100. Okay, and that's going to be so those are our new conversion factors. Yeah. From the conversion handout I gave you yesterday. It's on the left. Do you see it? So we've got so instead of centigrams, we're doing centimeters. How many cents are in a dollar? How many cents are in a dollar? 100, right? That's an easy way to remember it. Okay, now. So given has to cancel. But I saw a hand go up. It's not. All right. So it means meters is on the bottom. Now, someone always asks, every time I go over this problem is, do we square the 49? No, it's already been squared. If you square it again, it's gonna, two ways to do it. On your calculator, you have a little squared button. If you don't have a squared button, you just, the definition of squared means it's multiplied by itself. So if it's 100 squared, you go 100 times 100, or 100 square button on your calculator. Yeah. You have lab today? Yeah. You have hours in the lab. Hopefully not hours, but. Okay, all right, now we've got square centimeters. Now let's go to square inches. So we need to cancel a centimeter squared. That goes on the bottom. So meter squared, centimeter squared, cancel gives us square inches. So we're looking at so 3 sig figs, infinite by definition, and it's boldface, so it's also infinite. Now, if this was how many cubic inches are in 49 cubic meters, we would just do a cubic conversion. Instead of squaring it, we cube it. Same process, though. Now, many of you have not done one of these before. So it's very different. The other ones are kind of, I'm going to convert this to that, yeah. But this is a little different. Now you'll have one of these on your tests. We'll have at least one fraction problem on the tests. Now, on Friday, I'm going to go over a practice test with you. And between now and then, if you want to do it on your own, if you go to files, test related, you'll see practice tests there. Okay, are there any questions about this problem? Yeah. Yeah. You're gonna get the one that I passed out as a handout. Okay. When you remember, I want you to speak up though too. Remember, I'm old. Think about talking to your grandfather. What did you say? Okay. Okay. Cubic meters to cubic inches. Okay, so we're starting with 49. Now, cubic means three-dimensional. Square is two-dimensional. Length is one-dimensional. Yeah. I didn't hear you very well. Say,
Like where the implements, how would they be?
on the conversion factor itself. Yeah, just remember, when you're scoring something on the outside of parentheses, everything inside the parentheses is squared. Just a, it's just a shorthand way of squaring everything inside. So you have to square the units, you square the number. Was that your question? Mhm. They were what? Yes, the metric ones are all infinite. Because those are all by definition. The ones above the table there are only the bold-faced ones are infinite. All the others, the ones that are not bold-faced, you have to look at the sig figs and the number. Okay? Does that help? Okay. Yes. I multiplied 100 times 100, which is 10,000.
No, I didn't split 10,000.
Yeah, and 10,000 is 10 to the fourth. And remember, 1,000 is 10 cubed. And if you're going to multiply, so 10,000 is another 10 on there. That's why it goes from 3 to 4. Better? Okay, yeah. Yeah, Friday. I'm gonna go over a practice test on Friday. I will, but I don't know about your next teacher. And you don't have to say E, you just put E. And that's what your calculator does. When you punch E, on the screen, it shows as an E. But you can put E if you want, either way. It's fine. Yeah. Oh, well, let me do it again. I keep getting the same 10 to the fourth. Let me see. Yeah. Okay. 49. 3. in your calculator. Now, say you did that on the test. I would, mark up 1 point, but you set it as fine. And then give you. So do it again,
I know, I said my art side these out of sure that side's being here, but if there's no same. Yes.
You get the phone.
Yeah, it's still the same.
Okay, well, are you have lab today?
Yeah.
Okay, in lab, let's make sure it's. Don't worry, that's why you're in Chem A. Okay, it's really important that you understand that I'm assuming everyone knows nothing. And if that, use your calculators is an important skill because you'll die in 1A or 2. What chem are you taking next? 1A, yeah. They cover unit 1 in like a day and a half of lecture. And so the people that take Chem A do really well. And I mean, the people that take Chem A do really well in 1A, 2A, and 3A. They really do. Because we've knocked out all the confusion. And that's why Chem A I'm teaching next semester Chem 300 at Sac City, which is Chem A over there. And I'm going to use the same slides, everything the same. And that exists for the same reason this class exists. And it's okay to ask questions. All right, so let's do a cubic one. Okay, so we're going to, we need some conversion factors. Okay, 49 cubic inches. Now, we're not going to cube it because it's already been cubed. So we need, same as up here, actually. Only instead of squaring it, we're going to cube it. All right, so we're in 2.54. Okay, so 254 times 254 times 254. So we get to 16.4. 100 cubed. Okay. So we need to have the cubic inches. Yeah, the cubic inches need to cancel. And I'm going to officially run out of room here. Okay, so cubic inch cancels. So now cubic meter is big. Cubic inch is small. So you'd expect cubic meters to be number wise a lot less than what you started. Okay, we okay on that? Yeah. I'm sorry, what? Why did I cancel out? You mean on the 49? Because that's already been cubed. So if you cube it again, you're gonna end up with inches to the 6th power. So the given is already cubed for you. But our conversion factors aren't cubed yet, so we gotta cube them before we work with them. Does that make more sense? Okay. Yeah,
So you had 49, 16.4 on top. And then you cube that and divide by 10.6.
yeah. Do you not get the same answer as me?
I got it on my,
Huh?
I don't have my calculator, so I'm trying to do it on my phone, but it's just, so.
Phone calculators in general are marginal. Here. You have a laugh today?
No.
Okay. Yes. Okay, yeah.
So, if I understand it correctly, when the units of nitrogen cancel out, you just ignore the first square, the tangent solves out, and then you orbit the cube. And so it only matters when the units don't cancel out. So, for example, the 49.3 times the 16.4, and then, when it comes to the meter cubed, and the centimeter cubed and the other centimeter cubed cancel out, you still cube the result of the 40.
Yeah, it's there because it hasn't been canceled. And the game you play is you have the given and you do conversion factors to cancel everything out except for what you're trying to calculate. That's the game. And you keep throwing in conversion factors to do your canceling for you. It's just, That's the essence of all these problems. Yeah,
Is that a -3 or that is the regular 364?
it's on the bottom or the top?
The bottom.
Oh, it's cubic inches, so it's inch cubed. IN cubed.
Oh, so after I get the answer for that, then I just times it by 3, right?
No. You don't times it by 3. Cubing means the number times itself times itself. So 2 cubed, for example,
Oh.
is 2 times 2 times 2. That's 8.
So I got this.
Right.
So
So you're not dividing by 3, you're dividing by 100 cubed.
What? Where'd you get hundreds from?
Because there's 100 centimeters in a meter.
Oh, yeah, that's right.
So it's 100
Oh, that's the 300
better.
better.
It's not 300 though. It's 100 times 100 times 100.
Yeah.
It's not the same.
Oh, right.
Yeah, not 3 times 100. So that's where the 10 to the 6 comes in. Okay, any more questions? All right, one of the problems with algebra classes is they don't go over these practical problems. They give you laws of exponents. Now, I used to be a math major, and then my mini hobby is on YouTube, I always get these wild math problems, and they're entrance exam problems for schools like Harvard and MIT and stuff, solving them. So it's always fun to do those. And when I teach Chem A and Chem 300, my students aren't used to this. So when you run into a cubic meter problem, or a square, if you're going into surveying, they work with square miles, square yards, square hectares all the time. But that's about it. You just don't work with these square, or if you're buying a house, you're looking at square feet of the house. You just don't run into these squares and cubics very often. So it's just a matter of doing some. Now on your lab packet, Dry Lab 2, there's only one problem, the very last one. We need to do more of them. So you're used to this, converting a linear measurements into a squared measurement into a cubic measurement. So, was your hand up? You were scratching your. No, it hurt. Oh, okay. All right, are we okay? Back in the 60s, there was a book called I'm Okay, You're Okay. Is that book still around? Sorry. All right. We're looking at here. Convert miles per hour to meters per second. Okay, what's the given here? Miles per hour is the given. It's a fraction. Fraction problem. Remember the per? That's a fraction. Okay, so we've got and we're trying to calculate meters per second. Now, this is a fraction problem, and I've told you in the past that fraction problems are two problems. Breaking it down. So the numerator on the top problem, denominator on the bottom. Now, we're already in seconds on the bottom for both of them. So you don't have to do anything with seconds. It's already done for you. We just have to go miles to meters. Yeah. Per hour. Yes, it is that. Ferguson, how'd you get seconds? Okay, so it's not, it's back to a two-step problem. Okay, all right, so hours to seconds. Let's do that first. Hours are gotta cancel. It means it's gonna be on top. Okay. So now we got our seconds worked out. Okay, so we need to go miles to meters. Okay, so we've got miles to kilometers over here. And we can go kilometers to meters. So 1609. One conversion factor. Then we've got 1,000 meters per kilometer is another conversion factor. Okay, so we need to have the miles cancel. So it's already canceled, or it's already on the bottom, so that's good. And now it's in kilometers, we just get it over to meters. Okay, 3 sig figs. Okay, now here's another cubic one. We're going cubic inches to cubic kilometers, which is bigger, inches or kilometers? Kilometers are much bigger than inches. So if we're going to start with kilometers, we're going to end up with a whole bunch of cubic inches. So when you get your final answer, make sure that that number is big. Okay, so we're going to be using these conversion factors we've already done. Let's see, we get Okay, so let's do a quick conversion. And 254 we've already done, 16.4.
Can you just explain real quick what we're,
Say what?
can you just like explain like on the top row? Like the, just like. I think converting the,
The chart itself?
yeah, like what conversions?
Oh, we're using this one here. Using this one here. Inches and centimeters. And we're using centimeters to meters. And then kilometers to meters. Okay, and then so those are our converted cubic conversions. Okay, we're starting with 1.5. Cubic kilometers. And again, we're not going to cube the 1.5 because it's already been cubed. Okay, now we need a kilometers to cancel. I want the meters to cancel. And then we want the centimeters to cancel.
The 10 to the 9, come from.
10 to the ninth comes from 1,000 meters cubed. But
Get it. Awesome. Got it.
centimeters, there's 100 centimeters in a meter. And 100 is 10 squared. That's why I did this one compared to the one in your lab packet. Lab packet is very, most students have struggled with that one on the meters part. I mean, on the metric part. Okay, all right, so let's. Okay. There it is. Okay, now. 1.5 kilometers is like huge. 9.1 times 10 to the 13 is much bigger than that number. So logically, that makes sense. Now, the last problem on your lab packet is a little explanation on how to do this. And I don't think it's very good. So ignore that. Just look at the problem and do like we did in lecture. I think that's all the problem I had. Yeah. On the conversions of the, like the square and stuff. Okay, when we look at this number here, that's the conversion from going from length to square. So we have to square everything inside the parentheses though. That means the 254 is squared, the cm is squared, and then inches is squared. And then 2.54 squared is 645. Now the process we just did, we're gonna do the same thing with cubed. Well, instead of square, we're gonna cube it. So 2.54 cubed is 16.4. Yeah, everything has to be cubed or squared, except for what you're given. Mejor que antes. Okay, so let me show you. This is the practice test I'm going to go over next week. But basically, significant figures, scientific notation, sig figs again, just plain old multiplication division problems, taking into account significant figures, conversions, word problems. Now, interesting with this, on this problem here, my dad was in the Army during World War II, and he was in the aviation arm of the Army, no Air Force in World War II. And he was an aircraft mechanic. And he started in North Africa. He was fighting Rommel. And then he went from there to Sardinia, then Sicily, then southern Italy, up to southern France as the war progressed. He found in Africa a very interesting phenomenon done by the natives. What they would do is they would take a gold coin and they would buff off the gold until it was barely readable. Then they would go turn it in for a new one. Then they would buff off the gold. And so they would get about a gram per $20 gold piece. So the problem is, I told you how many gold pieces were minted and the population and the price per ounce. But this is a real problem. I mean, this really happened. Really kind of interesting. Anyway, so this is gonna be a typical test. And what I do, is I frequently will go through the practice test and change the numbers. So if you can do the practice test, you should be in good shape to do the real test. So I'm gonna go over this in detail on Friday. Okay, we may even do 2 of these tests. We probably have enough time to do 2. Now, unit 2 is we're gonna take what we learned in unit 1 and throw in some chemistry. We're gonna be using the periodic table, the numbers on the periodic table we're gonna be using, and we're gonna create a new unit called the mole, M-O-L-E. And it comes from the word molecule. And it's a unit used in chemistry, physics, and engineering. And moles rules. Everything is per mole in chemistry. Per mole, per mole, per mole. Kilocalories per mole. Grams per mole. Everything's per mole. Coulombs per mole. So anyway, the reason why we spent so much time in unit 1, making sure your math skills are up, because they're gonna get wild in the next unit. And wilder in unit 3. Because we're going from into solutions and acids and bases in unit 3. Okay, so that's it for today. Are there any lingering questions? If you're in a lab today, we can spend as much time as you want on any of these problems we talked about. All right.